Okay, now we're rolling. All right, so proving statements about segments and angles today. So yesterday, or the day before, I guess technically, you guys did some algebra proofs where one column was doing the steps of the algebra and the other column was explaining why you were doing it. Today it's going to be proving some statements about segments and angles where we do essentially the same thing, where the column on the left is going to be you explaining your steps of why your logic works, or not why your logic works, but what your logic is, and then on the right-hand column is going to be explaining why that logic makes sense, or why you are allowed to say whatever it is that you say. So these are all going to have kind of the same basic setup. There's going to be some little picture, and then there's going to be some given information. Okay, and our first task is going to be simply to mark up the picture so that it represents the information that's given. Okay, so here's our first one. So let's say we've got segment AD. We've got this other segment coming through it like that. And this is going to be segment BE. And the intersection is going to happen at C. Alright, so our given information for this is the segment BE bisects segment AD. And also, CE is congruent to CD. Now in the picture, oh yeah, the picture doesn't exactly look like that, partly because the projector stretches things vertically. So CE looks a lot longer than CD, but we have to assume those two are congruent. And what we're going to try and prove with this given information and given the way that the diagram is drawn, remember there are certain things we can assume based on the way the diagram is drawn. So given all of that information together, we're going to use some deductive reasoning to prove that the segment AC is congruent to CE. Okay, and I said the first thing we want to do is we want to look at the given information and mark the picture accordingly. Okay? So BE bisects AD and CE is congruent to CD. So the bisects thing, we can't really mark that up just yet the way that that's written, but CE being congruent to CD, we can certainly mark that in the picture. So we're given that this segment and that segment right there are the same length. Okay? And we want to prove that AC is congruent to CE. Now sometimes, depending on the proof, sometimes you can look at the given information in the picture and you can kind of reason your way through it. And then the task becomes, can you take that path that you kind of saw in your head of the way that the logic kind of works, and can you write that down in a way that makes sense? Any details? Okay, so can anyone kind of see the path we're going to take on this one based on the information that I gave you? Yeah? So, like start with the BE bisects AD. What does that tell us? That C is the midpoint. Good. Okay. So we know C is the midpoint. If we know C is the midpoint, what do we know? Yeah. Right, that AC and CD are congruent. And if we know that AC and CD are both congruent, and we also know that CE and CD are congruent, do you see how that leads us to AC and CE have to be congruent then too? Yes. Okay. So that's what I'm talking about, trying to kind of see the logic, see the steps ahead of time so that you can kind of start to organize your thoughts a little bit before you begin. All right? Now, if you can't do that, that's okay. All right? We can just kind of get started and then see if we can kind of slowly work our way through what leads to what as we go. You're not always going to be able to do that. But let's see if we can start this proof off here, though. All right, so I'm going to basically just do what you guys told me there. Okay, we're going to start with the given information. And I know sometimes it seems annoying to have to rewrite stuff that's already written up there. But technically this does need to be part of your proof because you can't do anything unless you know this information, so it has to be included as part of the actual proof. The two columns that I'm writing down here, that's the only part of this that's the actual proof. But on the bright side, if you copy down the given information as step number 1, if you're on a quiz or a test or whatever, and I ask you to write a proof, you've already got partial credit. Okay? No one. I don't care how frustrated you are with geometry or how confusing it is or whatever. No one in here should miss this step. Not a single person should ever leave a proof completely blank. Okay? Anybody can do this. Okay? I could teach my 5-year-old daughter at home to do this. Take what you see there, copy it down. Done. Okay? Get those points in the bank. Okay? Then let's worry about the rest of it. Yeah? Well, whatever is written here as given is given, whether or not it's marked in the picture. Okay? I was just marking the picture with things that I saw over here to help me. Okay? So, knowing that BE bisects AD will lead us to some things we could mark in that picture later, but yeah. So, okay, so step number 2. What was the next thing that you guys told me? I asked you, let's start with bisection. What does that tell us? Yeah. Okay. So that's exactly what I'm going to write. C is the midpoint of AD. Okay, and then Y. How do we know? Okay, so you're using there what it means to be a bisector, right? So if we're using what it means to be a bisector, I've just used the definition of a bisector, right? The definition of a bisector is something that crosses a segment at its midpoint, right? So my justification would be definition of a bisector. Okay, so then the logic's going to keep going like this. Okay, because C is the midpoint of AD, then what do I know? What does that tell me? What was the next thing that we said? Somebody other than Savannah this time. What is it? C being the midpoint, and you've already answered them too. What does C being a midpoint mean? Yeah, Abby? Good. Yep. So AC is congruent to CD. So what's my reasoning for that then? Why? Yeah. No. Yeah?
Because C is the midpoint.
Okay, so what am I going to actually write as my justification? Yep. Definition of a midpoint. That's exactly what I just did. Because it's a midpoint, I know these two things are congruent. That's the definition of a midpoint. Okay. So, we're kind of up to the end here a little bit. I've been able to get to the point where I can say AC is congruent to CD. So if I mark my picture that way, AC is congruent to CD, what I'm really seeing now is that there are 3 segments in that picture that are all congruent to one another, right? Okay, so let's think about what we're going to use to finish this thing up, because we're right there. We want to prove that AC is congruent to CE, and we've got that in our picture now. It's one of those are two of the three that we know are all congruent now. But really, all that we've stated in here, as far as things that are congruent, I haven't explicitly stated that yet. I've only stated that CE and CD match, and that AC and CD match. So can anyone think of a way that I can take these two pieces of information, CE congruent to CD and AC congruent to CD, to show that CE and AC go together? Yeah.
It's like the ball that A is congruent to B and B is congruent to C, then A is congruent to C.
You got it. And what is that called?
Oh,
Yeah.
the transitive property?
Yes, sir. We're going to use the transitive property to finish it up. Okay? We've got two things, two segments that are both congruent to CD, so they're congruent to each other. That's using the transitive property when you do that. Okay? So our last step in our proof then, we can say that AC is congruent to CE. And our justification for that, transitive prop. Now, technically, it's the transitive property of congruent segments. But if you just write transitive prop, that's fine. I'll know what you mean and know that you were doing the right logic for that. Okay? So then, if this step here matches what we were trying to prove there, we're done. Okay? So we've got a 4-step proof for this one that got us there. Okay? Now, something that I do, I was taught this in college. It's kind of an old school way of doing it, but I was told that when you are done with a proof, you always write Q, E, D to show that it's done. It's like a little stamp that you put on the end of it. And those 3 letters, it's Greek, because proving things in geometry started with the Greeks. That stands for quod erat demonstratium, which means, which is what we were trying to prove. It's the Greek for that. Okay? So QED, all you need to remember is QED means done. Now, I'm not going to mark things off if you don't put the QED on there, but I'm going to do it just because that's what I'm used to doing. Yeah. So, anyway, kind of a fun fact. Has anyone ever seen the first Pirates of the Caribbean movie? Yeah? Yeah, okay, so a long time ago. But, so in that movie, Johnny Depp goes on a tirade for a long time where he's like really mad at somebody. I can't remember what it was all about, but he was just like going off for a really long time about something, explaining why he was right and this other guy was wrong. And then at the very end of his rant, he screams QED.